Hey everyone, this is Exercise 5, Clustering and Segmentation by Team 3, Nathan, Sophie, myself, Freddie, and Mark. So here we have information about hierarchical clustering. So based on the YouTube video, what are some shortcomings of the hierarchical clustering? They are known to not scale large data, especially with a large number of clusters. And then briefly explain the main ideas underlying how Perch clusters data. So Perch is designed to scale to a large number of points and clusters. The purity enhancing rotations for cluster hierarchies is something that Perch looks at. They also consume data points one at a time and incrementally build the hierarchical clustering. And then when the data point arrives, it then routes it to its nearest neighbor, stores it in a leaf. If the program discovers that it is not similar to the leaf it is currently on, then it rotates to fit better, closer to a more accurate cluster. And then data points are added to bouncing boxes and adjusted to how similar the node is to other data points. So then based on the second video, this is k-means clustering. So what are k-means clustering algorithm main ideas? So k is the number of clusters that you wish to identify. So if your k that you input is 3, then you have 3 different clusters. They measure the distance between data points and the 3 initial clusters. They assign the data points to the nearest cluster, add variation within each cluster, and then calculate the mean of each cluster that is already present, and then forms new clusters based on those means, and then repeats this process until the clusters no longer change. Which it makes sense in my head. I don't know if the description makes sense, but it definitely makes sense in my head. And then what are some shortcomings of k-means clustering? So trouble clustering when the clusters vary in size and density, and then outliers can easily skew the clusters. So next we have the Moneyball example. So this is from SAS Viya. So we were tasked to find different clusters within the data set that we were given. So after careful consideration and an analysis of all options, our group decided that it is best to go with 5 clusters and only 4 bins, because 9 clusters was too many, the graphs weren't very clear, and the clusters were too similar. And then less bins made the clusters look more separated and clear and easier to draw conclusions. So group 1, we have FGM, FTM, 3PM, and points. So we can see that the cluster IDs are grouped by the different colors. The second group that we have is FG%, FT%, 3P%, and EFF. Also, the clusters are color-coded, and then these are some of the groups. And then we have group 3, which is BLK, TOV, STL, REB, and OREB. And those are also here. Thank you for watching.